All right, so the next lesson in module 6 would be to factor linear expressions. And our learning target, I can use GCF to factor linear expressions. Vocabulary that we are going to learn is factor, factored form, and the greatest common factor. Okay, so if I look at what does factor mean, okay, to factor a number means to write it as a product of its factors, okay, because when I multiply those two numbers, those are the factors, or three numbers, however many I'm multiplying, and then those are the factors for me to get a product. Okay, so if I say 10, I know that 2 times 5 is equal to 10. These are my factors which I multiply to get the product. Okay, so to factor a number means to write it as a product of its factors, like I said, and a monomial can be factored using the same method you would use to factor a number change. Okay, so the greatest common factor of two monomials is the greatest monomial that is a factor of both. And the greatest common factor also includes any variables that the monomials have in common. So we've done GCF in the past. So we find the greatest common factor, but we are also looking at any monomial which is common to both. Okay, so let's quickly look at some examples of solving, linear expressions like this. And if I have to find the GCF of monomials, okay, GCF of monomials, and I am given something like 12y and 30y. Okay, so there are several ways that we can find GCF like we've done in the past. We can already see that y is common, so that's going to be a common factor. And if I look at the numbers, let's look at the factors. What are just, if I take the factors of 12, if I take the factors of 30, what can I do to get 12? I can do 1 times 12. I can do 2 times 6. I can do 3 times 4, right? All these are going to give me 12. So if I list this, if I'm going to list these, my factors of 12 are going to be 1, 2, 3, 4, 6, and 12. Okay, and then if I look at 30, I know I have 1 times 30, I have 2 times 15, I have 3 times 10, and I have 5 times 6. Okay, so these are all going to give me how to find 30. Okay, so if I list these factors, here's what I have. Okay, so I have 1, 2, 3, 5, 6, 10, 15, 30. All right, and then I'm going to look at which one is the greatest common factor between these two. This is not the greatest. You have 1 common, 2 common, 3 common, 4 is not common, 5 is not common, 6 is the greatest common factor between these two, and so then 12, 10, 15, 30 are not common. Okay, so if I'm looking at this, the greatest common factor of the coefficients, because what is this? This is a coefficient of the variable, coefficient of the variable. So the greatest common factor over here is going to be 6. All right, but do I have a common variable? Absolutely. So my greatest common factor is 6, but both of them also have this common factor of y. So therefore, my greatest common factor of the monomial, the GC of the monomials, is going to be 6y. All right. So this is one method of solving it. Another method that I can use is by using prime factorization. All right. So I'm going to show you all different methods that we have done in the past. So if I'm using prime factorization for this, okay, so the prime factorization method, that means I am going to break this down into the prime numbers at the bottom. Okay, so if I take anything and if I say 12, I can use anything with 12. So I can say 3 times 4 is 12. I can say 2 times 6 is 12. It doesn't matter which of the factors I use, I will still come down to the lowest prime numbers. So over here I can see 3 is a prime number, but 4 is a composite number. So I need to break this down further. So I get what? 2 times 2. Now, think of it. What is 3 times 2? 6 times 2 is what I started with. So these are all the prime numbers at the bottom. So this is prime factorization. Let's look at 30. With 30, I can do 3 times 10 is 30, right? 3 is a prime number. 10 is a composite number because I can break it down further. And I get 2 times 5 gives me 10. Okay? Now I'm going to look at what do both of these have in common. So I can see that 3 is common to both. So I'm going to write it down. I'm going to see that one of the 2's is common to both, so times 2. Another 2 is not common, 5 is not common. What is 3 times 2? I get 6, and the variable here is y. So this is my greatest common factor using prime factorization. All right. Then here's the method that I had taught you in the classroom to find GCF really quick. So I am going to take 12 and 30, and I am going to see what are they both divisible by. Since we know our divisibility rules, and we can see that both are even numbers, we know that they are both divisible by 2. Okay, so 2 times 6 gives me 12, and 15 times 2 gives me 30. Then if I look at 6 and 15, I can see the divisibility rule for 3. And for 3, all I'm doing is adding the digits. And when I add the digits, that sum should be a multiple of 3, right? So 6 definitely is divisible by 3. What is 1 plus 5? Because that's basically, I'm thinking of the divisibility rules. 1 plus 5 is 6. So 6 is divisible by 3. So I know that 15 is divisible by 3. Okay, so I go up here again. I can divide both those numbers by 3, and I get 2 times 3 is 6, 5 times 3 is 15. Now, if I look at 2 and 5, the only common factor between them is 1. So that is in the simplest form up there. So the greatest common factor, as you can see, I am going to take this part and I am going to write G, because that 3 times 2 gives me what? It gives me 6. And that is the greatest common factor of the coefficients, 12 and 30. And then I can see that my variable is also a common. So therefore, 6y would be the GCF of the monomials that are present over here. Okay? So that is basically, you can use any of the 3 methods. You will always end up with exactly the same answer. Okay. Now, uh, to factor linear expressions, we can basically use the distributive property and work backward to express a linear expression as a product of its factors. Okay. So a linear expression is in factored form when it is expressed as the product of its factors. So let's talk about um, linear expressions as a product of its factors. So if I give you 12a plus 6b, and I ask you to factor this out, so we are going to see what could be the greatest common factor of these two numbers. Okay, so I can see that if I'm looking at the variables are different. Okay, so there's nothing common to the variables. But then if I look at the 12 and the 6, I know that my greatest common factor, both of these are divisible by 2, but they are both divisible by 6 also. It doesn't matter how you do it, you will end up with the exact same GCF. So if I do 6 over here, what do I get? I get 2 times 6 is 12, and I get 1 over here. So I can see that 6 is my greatest common factor. So I am going to rewrite this like this, okay? I'm going to write the 12a plus the 6b. So I'm going to see 6 times, what is this? So I'm going to write it like this. 6 times 2a gives me what? This gives me 12a, right? And plus, what do I have here? If I have 6 again, and then I have a 6 divided by 6 gives me what? 1. So 1b means just b, right? So I'm just showing you how I've split that apart. It's basically this 1 over here is over here. That's 1b that I'm talking about. And then if I was to rewrite, all I'm doing is this. 6 2a plus b, and that is the factored form of writing this. Okay, so if you look at it, and I'm using distributive property to show you, what is 6 times 2? This is 12a, 12a. Okay, plus 6 times 1 is what? 6, 6b. All right, so this is how we use the GCF and the, factoring it out. So this is two-factor linear expressions. All right, so let's go ahead and solve a problem. And if I give you 3x plus 9, if I give you 3x plus 9. So let's look at these two and see what do we have in common. Okay, so I'm going to look at I have a variable and I have a coefficient. Okay, so I'm going to take the 3 and I am going to take the 9. And I know that if I'm trying to find the greatest common factor, it's going to be 3. And I get 1 and I get 3 here, right? So I'm going to rewrite, I'm going to write 3 outside, okay? And then I am just going to take this part and I'm going to put it within parentheses because I am just writing it based on distributive property, okay? So 3 times what x? 1x, which is what? X. Because 1 times any number is the number itself. So 1 times x is x, plus, what do I have left here? 3. So 3. And so if I write it like this is the factored form. And let's see if that is correct. What is 3 times x? It is 3x. Plus 3 times 3 gives me 9. So this is the factored form using the distributive property. Let's try 6x plus 14. Okay, so let's try 6x plus 14. So if I'm again factoring it out, okay, I'm going to write the GCF over here, and then I'm going to put the plus because that's the sign over here. Okay, so let's see what this number is going to be. So if I take 6 and I take 14, I know that they are both even numbers, so they are both divisible by 2. And I get 3 times 2 and 7 times 2, 14. Nothing else is common between 3 and 7 besides 1. So I am going to write 2 over here. Okay, the GCF. This GCF is going to go outside. All right, and then I can see how many of this do I have? I have 3 x's and I have my constant of 7. Okay, so 2 times 3 gives me 6x plus 2 times 7 gives me 14. So this is how we factor out these numbers. Okay, what if I give you 12x plus 7y? Okay, so let's look at this. If I say 12 and 7, they're both not divisible by 2, 3, 4, 5. I don't see any number that they're divisible by, besides the only thing, the greatest common factor here is 1, right? So there's nothing common besides 1 to them. And even the variables are different over here. So therefore, in this case, there are no common factors. There are no common factors involved in this. So there are no common factors. All right. So same thing. If I say 12x plus 11, if I say 12x plus 11, is there anything common? No, because 12 and 11, the only GCF is going to be 1. So same thing again, there are no common factors with 12x plus 1. So I just want to show you this example also. All right, now let's do one last one where we are factoring using fractions, and it follows exactly the same principle with GCF. Okay, so if I give you a 1/4 x, 1/4 x plus 1/4. So let's look at this and see what could be common. Okay, so if I look at 1/4, I look at 1/4, that's the common factor right there. Okay, so I'm going to take this, I'm going to rewrite it like this with the plus in the middle. I'm going to put the common factor, which is the greatest common factor, outside, okay, the parentheses, and I can see that my greatest common factor is 1/4. Okay, and so 1/4 times what gives me 1/4 x. So 1/4 times x is going to give me 1/4 x, right? So I have x over here, so 1/4 times x gives me 1/4 x, and then I have 1/4 and 1/4. What am I going to have? Times 1. So 1/4 times 1, because any number times 1 is the number itself, right? So therefore, my factored form is going to be 1/4 x plus 1. All right. Um, and then let's just do a last one using fractions. If I have 2/3 x minus, I have 2/3. Okay, so let's look at both of these. What is the greatest common factor? It is 2/3. Okay, what do I have left? Since this is our 2/3 times x gives me just x left over, right? Minus it's going to be 1 because I have taken that 2/3 out. So 2/3 times -1 is going to give me minus 2/3. All right, so if you think of the distributive property, this times this gives me 2/3 x. This times this gives me minus 2/3. All right, so this is the factored method of linear expressions. Okay, so again, in this, please review your greatest common factor. There are 3 different methods I have taught you how to do this. One is by listing the factors and finding the greatest common factor. One is the prime factorization method. And then the last method that I had taught you using your divisibility rules, and then you just on the side what you have left, that is the g, and you multiply that. So whichever method you use, you will still end up with exactly the same greatest common factor. The greatest common factor is going to go outside the parentheses in the factored form, and then using the distributive property, you put the rest of the terms inside the parentheses. All right, have a great day.